All right, and here are some more notes for you to copy down other key characteristics of functions. We are primarily going to focus on increasing, decreasing, and constant portion of functions. So make sure you get that definition. The rest of this should be pretty familiar with to you at this point. X-intercept, Y-intercept. We've talked about what a vertex is. So let's answer the questions for this graph. First off, let's do the domain, and I'm going to use interval notation. Domain is the x's. It's how far left and right the function travels. It's a little tricky. This graph is obviously going down, but it is branching out to the left infinitely, and the right arrow, while it goes up, it's also going to the right infinitely. So the domain is negative infinity to positive infinity. Or I'm going to go ahead and write set builder notation because that's used a lot when the answer is all real numbers. I just wanted to show that notation again. The range is how far north and south this graph goes. So even though we have a relative maximum here and a relative minimum here, this arrow overtakes this hump right here. So it does go up forever, and this arrow down here is going down infinitely. So the range is also negative to positive infinity. And again, set builder notation, all the y such that y is all real numbers. Next up is in behavior. This one, first off, is the right end as x approaches infinity. So that's our right end right here. As x is getting big, what's happening to y? Well, this graph is going up as it moves right. And then we look here, for the other one, we look at the left end as x approaches negative infinity. Means we're looking at this left arrow, which is going down. So as x is getting small, so is y. We have to estimate on some of these. The x-intercept is where it touches or crosses the x-axis. So it has several. Here's an x-intercept. So all together it's got 3. One at -4. We have one at -1 and one at 3. We could write these as ordered pairs as well. It's not necessarily wrong. And then y-intercepts, where it crosses the y-axis. Looks like it just crosses the y-axis one time right here. We'll just estimate that's at about 0, -2. A 0 is where the function is equivalent to 0. But basically, x-intercepts and zeros are the same thing. We use zeros more when we get into the quadratics unit. And then finally, increasing, decreasing constant. Here's the part that can be tricky. So increasing, decreasing constant, we go by the y values of whether it's increasing or decreasing, but our answers only use x's. So our answers, we're going to be using the x coordinates for these 3. So here's what I want to do. I want to go from left to right. That's how we read a graph, just like a book. So here's the leftmost point, basically, that I can see. And I'm going to go left to right. Well, what is happening as we trace this line from left to right? We're going up, right? So this section is increasing. And since we use the x coordinates to write that answer, the leftmost x coordinate is -infinity. And it stops increasing here at this point, this relative maximum. and that x coordinate is at negative 3. So stops increasing at x equals negative 3, starts increasing at x equals negative infinity. All right, then that middle section starts here, and as we go left to right, we are obviously going down. So this section is decreasing, and it's decreasing from negative 3 until it stops at about x equals 2. And then finally, the last part of this graph is here at 2, and now we are increasing once again. So we increased from negative infinity to negative 3. So I'm going to write a U for union, and it begins to increase again from 2 to infinity. Constant, it's not constant anywhere. So I'd encourage you to pause the video and try this next example. I'm first going to do domain, range, and behavior, and I'll show that answer here in about 5 seconds. So here's what I got for domain and range. And I wrote domain and range in a couple of different ways. The in behavior, as they have it set up, there is not an answer. They could have changed positive infinity to 6 and negative infinity to negative 6, and then there would have been answers. But the way they have that one set up, there's no answer. Encourage you to pause the video one more time and try this last set of problems. So here's our intercepts and our zeros. And let me just go ahead and do increasing, decreasing. This can sometimes be tricky. So again, we're going to start from left to right. Just like we read a book, it's how we read a graph. So the leftmost point is here at this open dot. And as we move left to right, we're obviously decreasing. And remember, we use x's here. So that leftmost x coordinate is negative 6. The rightmost x coordinate is negative 2. So that first section is decreasing from negative 6 to negative 2. And we always use parentheses here. Since there's some overlap with increasing and decreasing, we never want to use brackets. All right, then the next section, here in the middle, this is a flat line, so that is constant from x equals negative 2 to x equals positive 2. The next section, from left to right, we are going uphill. So that section is increasing. And it's increasing starting at x equals 2 and ending at about x equals 4. And you'll notice these solid dots did not affect the domain and range for this problem because they're not the left or rightmost point. I should say they didn't affect the domain. Then finally, this last section of the graph is decreasing because we're going down from x equals 4 to x equals 6.